PPT, I have changed it. I changed the entire scenario, which I'll let you know. Perhaps after this, we'll start module 5. In module 5, anyway, we are done with Bezier curve. The first part is remaining, and other couple of things in the later part of the module 5. Module 5's first half is pure theoretical. We will do it, I think, tomorrow, which I thought of doing it today itself, but since many people ask me to do this 3D rotation in a non-vector way, which we will do today. All right. So let us start today. Just a recap: 3D transformations. This is in module 3. 3D transformations. 3D point, as you know, it is represented via XYZ. To make the machine understand, we add a homogeneous coordinate y homogeneous to eliminate additions, and of course to um, do this transformations, which are of 5 types: translation, scaling, rotation, all those. 2D translation, rotation, scaling, these what we saw, and we add a new matrix here. We in translation we multiply 1001, in rotation we add 00, in scaling we add 00, and the generic equation is this. So the what we can see is it has multiplication as well as addition. So generic form is this. Is there any way to avoid addition? Well, the answer is homogeneous. This is what we got, and you can see no addition here. To support the defense, uh, you can see here, yeah, this is with addition 8,6, and without addition also, with the help of homogeneous, we got 8,6. So in effect, we don't lose anything. Main advantage is it is easier, and everything is matrix multiplication. All this we saw: 3D 3D rotation, coordinate system, right hand, left hand. Uh, 3D transformations, homogeneous coordinates is 4 plus 4. The matrix translation is simple: x y z going to x dash y dash z dash, and the inverse translation is coming back from wherever you were. 3D rotation, this is the main stuff. For 3D rotation, you should of course know the rotation axis and an angle. 3D rotation are of 2 types, sorry, 3 types. One is keeping x and y z in mind. Second one, taking your own axis, which is parallel to these x y z axis. The third type is, which is quite difficult, your own axis not parallel to the coordinate axis. This is what I had given in the test, and in the textbook it is being done via vector multiplication, dot product and cross product, which I have avoided in my PPT. I have gone behind plain trigonometry. All right. So first we will see the coordinate axis. Similar to the 2D rotation, just add a new row. So if you want to rotate any object via z-axis, coordinate axis means, understand, it is x, y, z. If you want to rotate an object via z-axis, this is the matrix we saw in 2D. Since you are rotating an object via z-axis, z-axis remains unaffected. That is why it is z dash is equal to z. And you can see in the third row, third column, it is 1. So 1 in the sense doesn't affect. So x and y gets changed. And this is the rotation. And this rotation matrix you need to multiply with every point. This is about z-axis. X-axis is, take the same equation, replace wherever you have x, replace with y. Wherever you have y, you replace with z. So you can see this x will now become y, y will now become z. So same equation, it comes here. And the matrix, since you are rotating an object via x-axis doesn't get affected. That is the reason first row, first column is 1, and second row, third row is your cos minus sine cos. Y-axis rotation, take uh, x-axis formula because y comes after x. So take x-axis formula and replace wherever you have x, you have replaced with y. Wherever you have y, you replace with z. For example, you can see in the x-axis rotation, I have y cos theta. So y should be replaced with z. So it becomes z cos theta. Z is here, so z should be replaced with x. So it becomes x sine theta. So since you are rotating via y-axis, the second row, second column remains unaffected. So first row, third row, that is the x and z, z dash, x dash. So those guys will be affected. So these all these we have seen. Second one, you take your own axis, uh, align that axis parallel to the x or y or z. So for example, something like this. Your own axis in the sense wherever you are viewing. This blue color line is your viewing axis. So in this diagram, you can see your axis is parallel to z axis. Your axis is parallel to x axis here, and in the last one, your axis is parallel to y axis. So how do we do this? Well, first step is your since your here in this example we have taken arbitrary axis. Arbitrary axis in the sense your own axis. So if that your axis is parallel to x-axis, first what you need to do is bring that parallel axis and merge it to x-axis, because here in this slide the example axis is x-axis. So bring your axis, merge it to the x-axis, and then rotate, and then go back to wherever you are. So first step is positivity, next is rotation, third is inverse. You should do all this for every point into p. All right, you can see here this red dotted line, bring to first step, bring to the x-axis, second step rotated, third step you push back. All these we have seen. So what is the big deal is this guy, arbitrary axis, that is your axis, not parallel to the coordinate axis. Example, something like this. So this blue color line, you can see it is neither parallel to y nor x nor z. How do you rotate an object? Okay, you can ask me one question. What is this coordinate axis or arbitrary axis? Understand, if you want to rotate any object, you cannot rotate the object in space just like that. You need to have an axis. That is, you need to have a reference axis. That is what you call as arbitrary axis. That reference axis can be a coordinate axis. Means if you don't have your own reference axis, you can imagine that you are rotating an object keeping x in mind or y in mind or z in mind. That is what we have seen all these here, keeping x-axis, y-axis, z-axis. But what if you have an reference axis which is not at all parallel? That is why the word called arbitrary. So this is a big deal because you are rotating a 3D object in a space, considering or keeping the arbitrary axis in mind. So how do you do it? How do you rotate the object? There are 5 concrete steps. First step is bring that arbitrary axis to origin. Second step, somehow rotate that axis onto example z-axis. You can take it as x-axis or y-axis, but 3D rotation always should be done, or not should be, it is better to be done via z-axis, because through z is where our eye with the camera points at z-axis. If you look at GLU look at, you can see ix, iy, iz. So the z-axis plays a big role there. So second step is rotate that axis, blue color axis, towards your z-axis. Third one is rotate your object. Fourth one, go back to the origin. That is called inverse rotation. Fifth one, go back to wherever you were. It is called inverse translation. So second step, that is bringing the arbitrary axis onto the z-axis, involves rotating that particular axis via x-axis as well as y-axis. Simply in 3D, if you rotate an axis or object, means you are actually rotating x, y, z. So that's the reason you should have to rotate keeping other axes in mind. So whatever we discussed, these 5 steps, let us understand better in this video. You can see here. Yeah, there is this arbitrary axis. The teapot is your object. You can see that is neither parallel. First step is bring to origin. Second step is put it to z-axis. Third step is rotate the object onto the z-axis or with respect to z-axis. Fourth one, rotate the arbitrary axis to the origin. Fifth one, go back to wherever you were. Let us have a quick look again. This P1, P2, that is your arbitrary axis, and the teapot is your object. First step is bring that axis to origin. Yeah, bring it to origin. Second, rotate it to z-axis. It involves x and y as well, of course. Third one, rotate it with respect to z-axis. Fourth one, rotate back to origin. Fifth one, go back to wherever you were. That's the reason I told you, yeah, these 5 steps. Rotate back to origin, rotate and go back to wherever you were. So let us understand uh, step by step. And as I told you, if you want to rotate it, which is about the arbitrary axis, which is not parallel to the coordinate axis, you should take care about all these x, y, z. All right. So if you dive deeper, this is how the textbook example talks about initial position. First step origin, second step put it to z-axis. This step 2 has 2 steps. I have considered as step 2a and 2b. 2a is rotating via x-axis and 2b is rotating via y-axis, and step 3 is rotate the object, because you would have rotated the axis towards the z-axis. The step 3 is, of course, you need to rotate your object via that z-axis. Step 4 is rotate that axis. You can see in step 3 the arrow mark is towards z-axis. The blue color line, the arbitrary axis, the arrow mark is towards z-axis. Fourth step is rotate that arbitrary axis to the origin. You can see the arrow mark is in now first quadrant. Fifth step, go back to wherever you were. So in all these steps, you can see as and when you play with the axis, the blue color line, the arbitrary axis, your object also gets affected. The final equation is this. It should come from the reverse. First step is P, that is pulling to origin. Second step is, as I told you, it is step 2A, 2B. So rotate it, you can see here, rotate it via x-axis, some alpha degree. Next is rotate it via y-axis with some beta degree. These two corresponds to step 2. Step 3, rotate it, because you are in the, you can see here, my example axis is z-axis. So rotate the object via z-axis. He would have given the theta angle. I know the example would be, we will solve it later. Rotate this particular cube or object with respect to z-axis 90 degrees anti-clockwise or clockwise. So that 90 is your theta, not alpha beta. So once these are done, you should nullify the effect. That is the fourth step. That is inverse rotation and inverse translation. Inverse rotation means step 2, that is Rx alpha, Ry beta, you need to nullify it, you need to reverse it. So that is why Ry minus of beta, Rx minus of alpha. That is wherever you have uh, x, or wherever you have theta, you make it as minus. And t minus means wherever you have written minus x minus y minus z, you make it as plus x plus y plus z. That is your fifth step going back. Now all these we have discussed only theory. Now let us do the mathematics. All right. Now first step, translate the rotation axis through the origin. All right. First one. Take the blue color axis, that is the initial position. You need to put it to the origin. Now here comes, what do you mean by vector? Now this arbitrary axis, you can see we have p1 p2, and let me call that as a vector. And somewhere here you will have an object, a teapot or any object which needs to be rotated. Now let me consider that arbitrary axis which is in space as a vector. You know, vector is nothing but um, it has a magnitude, it has a direction. You can see the direction is pointing towards up. Now if I scale down, and if I write, or if I denote p1 p2 in terms of coordinates, so p1 has x1 y1 z1, p2 x2 y2 z2, and u is my unit vector having the coordinates abc. Now what do you mean by a is direction cosine of x, or in other words, x2 minus x1 divided by the magnitude of the whole vector, something like this. U is ABC, where A is x2 minus x1 divided by the magnitude of the vector. Magnitude of the vector is square root of this x2 minus x1 comma y2 minus y1 comma z2 minus z1. B is the direction cosine of y, or B is y2 minus y1 divided by the magnitude, because these are all vectors. Now if you uh, pull this unit vector onto z axis, sorry, onto the origin, this is how you will find it. So this axis has been pulled to the origin. But the point is, we have only discussed the mathematics, we haven't applied it. Okay, now that we will apply. Now how do we pull this p1 p2 to the origin? Now the common understanding is, if I just pull p1 to the origin, p2 obviously follows. Now P1's coordinate is x1, y1, z1, positive, positive. So how do I pull this to origin? I should apply minus x1, minus y1, minus z1. To make you understand in a nice way, consider P1's coordinate is 10, comma 20, comma 5. How do I get this 10, comma 20, comma 5 to 0, comma 0, comma 0? I should subtract equal amounts of x, equal amounts of y, equal amounts of z. That is minus x1, minus y1, minus z1, minus 10, minus 20, minus 5. So 10 minus 10 is 0, 20 minus 10, 20 is 0, 5 minus 5 is 0. That is how P1 comes to 0, 0, 0. Naturally, P2 also follows. So whatever P2's x2, you are actually subtracting by x1 amount. Y2 gets subtracted by y1 amount. Z2 gets subtracted by z1 amount. We will see that in the problem. Now net effect is, this is the input, this should be the output. This is the mathematics. So we know the translation matrix 4 cross 4 have the help of homogeneous. It is actually x1, y1, z1, but since we are pulling x1, y1, z1 to origin, We should be doing it minus x1 minus y1 minus z1. Y minus, as I told you, x1 y1 z1, if that is 10 comma 10 comma 5, how do I get it? 0 comma 0 comma 0. I should subtract 10 with 10, 20 with 20, z with 5 minus z. That's the reason it is minus x minus y minus z. Now you can ask me one question: what happens if this is plus x y z? Now if you imagine x1 y1 z1 as 10 comma 10 comma 5, this will now come to, this will now go to plus 10 plus 10 plus 5. That means p1 will now go to 20 comma 20 comma 10. You're not pulling me to the origin, you're making me to go away, so which you should not. So the first step always says translate the arbitrary axis to origin. So instead of taking care of p1 p2, you can just pull p1 to origin. You can also pull p2 as well. So in which case, if you want to, if the arrow mark is ulta, the reverse, so the arrow mark, that is the unit vector is going via from p2 to p1. In that case, you could have pulled p2 to origin. So since the arrow mark is from p1 to p2, it makes sense if you to pull p1 to origin. So this is the input, these two are the output, and this is the mathematics. So step 1 is over. Step 2, rotate it. What you need to rotate? This blue line, the output of the first step. Now the blue line is p1 is origin, p2 is here, the arrow mark is in the first quadrant. Now what the second step says, the arrow mark should now come to z axis. Now since it is in the first quadrant, it will not simply come to z axis. So you have to rotate it some bit, some angle with respect to x axis. You need to rotate with some angle with respect to y axis. Then only you can put it to z axis. That's the reason I have, you can see here, come reverse t, that is over. So step 2 is, there are two steps, two sub steps. One is you need to rotate it via some angle alpha with respect to x axis, and this output should be given as input to step 2b. You need to rotate that axis with respect to some beta, some angle with respect to y axis. Then only you will get that particular blue line onto the z axis. Step 3 is simple. Rotate, you would have given 90-degree or 120-degree theta, just rotate it with respect to z axis, the simple plain old equation. And then you need to do the inverse, nullifying the effect. Now we'll consider step 2's first step, that is called step 2a. Now step 2, how we can do is, this is the first diagram is the output of step 1. That is, the axis was here and you p1 you pulled it to the origin. So this is the output of step 1. So what you need to essentially do is, as I told you, your intention is to make this u onto z axis. Simply you cannot in one shot put it to z axis. You cannot. So since it is a 3D space, the moment you rotate, you're actually taking into consideration the x-axis as well as y-axis. So step 2a is somehow make this u, rotate it anti-clockwise and pull it to xz space. Now it is in xy space. Somehow pull it, somehow rotate it. If you rotate the axis, obviously the object also gets affected. Now the first step is the u which is in xy, put it to xz, step 2a. Now this should be the output, I mean this should be the output of 2a, this should be the input to 2b. Now 2b's or 2a's output is in the second diagram. So you can see the unit vector u is in xz. You need to now pull this anti-clockwise via some angle beta with respect to y-axis, and thus your u will now come to z-axis. So now we'll see step 2a, how exactly you can pull this unit vector which is in xy plane, that is the first quadrant, how exactly you can rotate this to xz plane, keep rotating via x-axis. All right. You can see step 2a theory, rotate this u around the x-axis, which is now actually in the xy plane. You need to rotate in such a way that it should now come to this xz plane. It can be accomplished by rotating u dash. What is u dash? The shadow of u, something like this. U is here. You are actually seeing from this angle. If you see this dotted line is your projection, the shadow. So I told you this is your lookup, you know, uh, where exactly camera is pointing to. Camera in terms of computer, in human beings it is our eye. So our eyes is looking at you from this way. So the shadow falls or the projected points is now u dash. That is what he says. U dash is the projected point, projection of u in the yz plane. So this is your yz plane. U gets projected as u dash. Since you are now rotating via x-axis, rotate this u around x-axis. X-axis doesn't get affected. That is why it is written as 0, and others will get affected. We see. Now, at the same point, if you look u dash from this angle, that is from a y angle, its shadow will now fall to uz. But since I have to rotate this axis anti-clockwise so that it comes to xz plane, I cannot consider this 0, u dash and uz. And if I want to rotate it, of course I should have cosine and sine. And the sine and cosine comes only if you have 90 degrees. That is, the trigonometry actually happens if you have 90 degrees. So what we will do is we will pull a normal. We will write a perpendicular line, and this becomes your 90 degree. And let this is your alpha. Alpha means some rotation angle with respect to x-axis, so that if you keep on rotating u dash, you keep on rotating u dash such that u dash will now come to xz plane. To make you understand, let us say alpha is 30 degrees. Now what we should do is u dash, you need to keep on rotating 30 degrees anti-clockwise, like this, such that u dash now comes to xz plane. That is what is your alpha. Now, since you have drawn a perpendicular line, this is your 90 degree now, and this can be alpha, the 30 degree, whatever, and u dash is 0 BC, where this particular normal line, this can be your B, and this can be your C. Now, if you're applying cosine and sine, this is your adjacent, this is your opposite, this is your hypotenuse. Now, if this is B, if this is C, hypotenuse is obviously, apply Pythagoras theorem, it is root of B square plus C square. Now, let me call that root of B square plus C square as D. So, D is equal to root of square root of adjacent square plus opposite square, Pythagoras theorem. Now since I'm rotating this axis, let me take the cosine and sine angles. Cosine of alpha is adjacent by hypotenuse. Adjacent is c, hypotenuse is root of b square plus c square, that is d. So it is c by d. Sine alpha is opposite by hypotenuse. Opposite is b divided by hypotenuse is square root of b square plus c square, that is d. Okay, here is where we are avoiding vector cross multiplication and dot matrix multiplication, which is there in your textbook. All of you have followed that. If you have understood that, just go ahead. Else, this is the way. Okay. So cos alpha is c by d, sin alpha is b by d. Okay. Why have we calculated all this? Okay. We have rotation matrix for x-axis. You can see x-axis is 1 because if you rotate any object via x-axis, x-axis first row first column doesn't get affected, which we saw in I think some 10 minutes back. I told you how do you rotate via x-axis, y-axis, z-axis. So x-axis means first row first column doesn't get affected. In other words, if you rotate any object via x-axis, its x-axis value doesn't get affected. Y and z gets affected. So we have this formula. Whatever we have calculated cos alpha and sin alpha, it is our duty to substitute these guys c by d, b by d in x-axis rotation matrix. So where you take x-axis rotation matrix. So wherever you have cos theta, replace with c by d. Wherever you have sin theta, replace with b by d. That is how you get this. This same thing in the textbook has been taught via dot matrix vector cross product multiplications. All right. So 2a is over. Now I have taught you theory here, the mathematics and the matrix equation. What is the result? So step one's output, which was something like this. Step 2a's output is we have somehow aligned this u in which is in xy plane to xz plane. Xz plane. What is this a comma 0 comma d? I'll talk about that in 1 minute. Now just go back. Yeah. This u dash, what we understood now, let us say this alpha is 30 degrees. You need to anti-clockwise way keep on rotating u dash, which is the projected point of u, 30 degrees. Keep on rotating such that this u dash will now come to xz plane. Okay. Now the point you need to understand is, I told you 30 degrees, keep on rotating. It comes here, 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 here. Eventually, it now comes to uz. This u, if you keep on rotating 30 degrees anti-clockwise bit by bit, bit by bit, this u dash will now merge to uz. There's a difference between uz and c. C is only this part. For example, if you from 0 comma 0 comma 0 to uz, if this is 1 kilometer, the c is around, let us say, a half kilometer. So this from 0 comma 0 comma 0 to u dash, this is 1 kilometer. So 1 kilometer, if you keep on rotating via 30 degrees bit by bit, bit by bit, somewhere this 1 kilometer will now touch uz. So in a sense, at some point of time, eventually u dash will now become uz. But what is u dash? This the length, the d, that is root of b square plus c square. This d will now become this uz, which will help in our 2b. All right. So 2b, is 2a's output, that is the u in xz plane. You need to rotate it such that anticlockwise, such that this u will now be aligned to z axis. How do we do it? Now we'll go back to this. I told you this d, when you rotate anticlockwise such that it comes to xz, eventually u dash will now come to uz before it is going to xz plane. All right. Okay. That is the reason this uz is now d, is now d. I'll repeat. This 1 kilometer, if you rotate it, it will now eventually come to uz. That is your d, 1 kilometer. So here 0,0,0 to uz, that is your d. Once it touches, of course 2a tells you to go till xz plane. So this is your 2a's output. Okay, now we have understood what is this distance. This is your 1 kilometer. Now this is the output of 2a. Now what is this a comma 0 comma d? Now since we are now rotating via y-axis, okay, step 2a, what we did, we rotated this u keeping x-axis in mind. That is the reason we applied in x-axis equation. 2a is all about x-axis rotation. That is the reason first row first column is 1. Now once we got 2a's output, we need to now rotate this 2a's output keeping y-axis into mind. Now since you will rotate u double dash, that is the output of 2a, which you had rotated onto x-axis. This is the output of 2a. Now x-axis rotation is over. Now you need to rotate this around y-axis. You can ask me why. I told you already, in 3D space, if you want to rotate any object via z-axis, means that object also gets rotated via x and y. So x-axis is done. Now let us rotate this u double dash, that is this axis, with respect to y-axis, such that this guy anti-clockwise way will now come to this plane, not uz. It will now be aligned, that is, it will now be merged onto this z-axis. Remember, 0 comma 0 comma 0 to this z is what we should have, not 0 comma 0 comma 0 to uz. You can see this normal here, this not normal, this is the normalized vector, normalized cone volume. So this is what we want, not uz. But uz, we know it is d is equal to, that is, this is the d, and how it is a comma 0 comma d. Now let us talk about 0 first. Now this is x comma y comma z. Y is 0. If you remember here, it was x was 0 here. Why? Because we rotated around x-axis. Here we need to rotate this arbitrary axis onto y-axis. That's the reason y is 0 here. And since a and z doesn't get affected, a remains as such. Z is actually this distance which I talked here. If you rotate this 1 kilometer, eventually it will now touch uz, that is your d. Now since that is d, z axis becomes d. Now your actual triangle is 0 comma 0 comma 0 u double dash, and this and this z, not uz, this z axis. This dotted line here, this is your view volume. But trigonometry applies is applicable only for 90 degrees. So let us draw a normal perpendicular line such that this guy is 90, which is actually this 1 kilometer distance. That is your user. Now, since we have 90 degrees here, we can now consider this angle as beta. What is this angle is, for example, let us say this beta is 50 degrees. The common sense is u double dash. You can imagine this distance as, let us say, 2 kilometers distance. Now this 2 kilometers axis, you should rotate 50 degrees anti-clockwise. Keep on rotating this guy 50 degree, 50 degree, 50 degree. Keep on rotating such that at some point of time it will now merge to this z axis, not uz, from 0 comma 0 comma 0 to till this z axis. So it will be now merged to this z axis, and then we can rotate the object via z axis. So that is the common sense understanding of beta. Okay. Now to get this beta, we need to have a normal or perpendicular line. That is why we drew a perpendicular line to this z axis such that this is 90 degree, and obviously this is your beta. Now if this is beta, this is your opposite a, because u double dash a comma 0 comma d. So this is your x-axis a, and this is your adjacent d, and this becomes your hypotenuse. So if the other sides is a and square root of b square plus c square, the hypotenuse, apply Pythagoras theorem, it is root of other squares. So it is a square plus square root of b square plus c square whole square. So square and root gets cancelled. It is b square plus c square. So this length, this 2 kilometers length, it is root of a square plus b square plus c square. All right. So this is opposite, this is adjacent, this is your hypotenuse. Now you apply cos beta. Cos beta is adjacent by hypotenuse. Adjacent is root of b square plus c square, that is d, divided by the whole root of a square plus b square plus c square. Now, since this is unit vector, you can consider this value as 1. So it becomes d by 1, it is d. Sin beta, it is opposite by hypotenuse. Opposite is a divided by this hypotenuse. This can be considered as 1. So it is a by 1 a, because it is unit vectors. So cos beta, sin beta we got as d and a. Now let us substitute in the y-axis rotation matrix. Why? Because step 2b is all about y-axis. That is the reason the second coordinate is 0. So y-axis rotation we know. So substitute these cos beta, sin beta onto y-axis. We will get this guy. In textbook, they have gone via dot matrix and cross matrix. So 2b is done. The theory is done here, mathematics and the equation. Now let us see the result. So 2a's output a comma 0 comma d, we have now rotated anti-clockwise via some beta degree such that it now comes to z-axis. So this is initial, this is step 1, this is step 2. The arrow mark, you can see in the step 1, the arrow mark is in xy plane. Now it is in the z-axis. That's what I told you. In 3D space, you cannot simply rotate an axis and merge to an axis just like that, or in one shot you cannot do it. You should take care of other axis equations as well. So 2b is done. Step 3 is what? we have an object here, you need to rotate it on z axis. So normal equation here, z axis we know the formula, the matrix. So just apply this one. This theta he will give you. So in the question, he will give you rotate an object with respect to z axis. Uh, the arbitrary axis is not parallel to z axis and rotate it via 90 degrees. So the theta will be given. So apply this matrix. Step 4 and 5, it is very simple. Step 4 is actually step two's inverse. Step 5 is step one's inverse. So just wherever you have plus, you write it as negative, which I will show you in the formula. So in conclusion, 7 series of operations come from the reverse. First is positive translation, and Rx, Ry rotations, and then Z rotating that particular object via Z axis, and X and Y negative rotations, and T minus negative translation. Alright, you can see in the animation here alpha, some beta, and some theta. Okay, so put it in other words, let us say understand this black color dots is your vector, and this red color line is your u, that is your unit vector. It has p1 p2. I told you x1 y1 z1, you should pull it to origin, and x2 y2 z2 also follows. So x1 y1 z1, how do you pull it to origin? You need to subtract minus x minus 1. So this step 1 is over. Step 2a, you are seeing from here, this is your view volume, normalized view volume, and 0, that is the projected point. You are rotating via x-axis. So we got this v by d, c by d, we applied all this. Fine. Step 2b, 2a's output is here. You need to rotate it such that it comes to and comes and aligns onto z axis. So we saw all this, and he has taken d by l. L in the sense this your root of a square plus b square plus c square, which we evaluated as 1 for unit vector. For not a unit vector, you can consider as d by l. D by that square root of a square plus b square plus c square, that he has taken as L. In our case, it is d by 1, it is d, d minus a, ad. So this is ry of beta, and rz of theta is this formula. Next is inverse. Yeah. So you can see here, wherever you have plus, you write it as minus. That is, a row should be converted to column. For example, 2a, it is, you can see a cos minus sine cos. The opposite of this, the inverse of that is cos sine, that is cos minus sine, the row major, make it as column major, that is cos minus sine, that is what it comes, cos minus sine, and sine cos is here, means to step 2a, sine alpha cos alpha is in third row, second column, something like this, sine alpha cos alpha. We have taken row major, and inverse should be column major, that is sine alpha cos alpha. This is step 2a. Step 2b's um, inverse is, go to 2b, you can see here cos minus sine is here in the row major, put it in column major, so it becomes cos minus. 2b again, my this one, sine beta cos beta, row major, third row, put it in column major, so sine beta cos beta. This is your inverse. Okay, now we have understood why it is a big deal, right? So we had this blue color axis, put it to origin, straight away we got it to z axis, which will not happen. You know, it goes through x axis alpha and y axis beta, and then comes to this step 2. That is the reason I told you step 2 has two parts, 2a and 2b. Third is rotated, fourth is inverse rotation, fifth one is inverse translation. Now, all these while we have understood the theory. Now, let us apply it. This is the last part of the segment. This is a unit cube. He says rotate this 90 degrees anti-clockwise. I mean, if he has not given anything, understand it as anti-clockwise so that our theta can be positive. But he continues the question, says rotate this cube with your own axis, that is your arbitrary axis, which has the endpoints 210, 331. 210, 331, you can draw a line here. Now 210, 331. So this is your x1, y1, z1, p1, x2, y2, z2 is 331. Okay, now we'll apply all these whatever we learnt. Okay, first one, translate that unit, that is arbitrary axis to origin. Now I told you the A is P1, B is P2. Here. You can consider, yeah, x1, y1, z1, x2, y2, z2. This is your A, this is your P, this is your P1, P2. So pull this P1 to origin. That is what it should do. Minus x1, minus y1, minus z1. We are least bothered about x2, y2, z2. It follows. So we'll now do it. So what is A? 210. So you need to subtract minus 2, minus 1, minus 0. So that A comes to origin. So 2 minus 2 is 0, 1 minus 1 is 0, 0 minus 0 is 0. Since B follows A, so whatever proportion you have subtracted to A, you need to subtract the same amounts for B. For example, A, it is 2. Now you are subtracting minus 2. So that A comes to 0. B, A's y coordinate is 1. You are subtracting 1 minus 1. And A's z coordinate is 0. It is minus 0 or 0. Now the point is you have subtracted 2, 1, 0 of A. You need to subtract 2, 1, 0 of B now because B follows. So 3 minus 2 is 1. 3 minus 1 is 2 and 1 minus 0 is 1. That is the reason this B is now 1, 2, 1. A became 0, 0, 0 because it was at 2, 1, 0. We subtracted the equal amount. It became 0, 0. So subtract 2, 1, 0 from B. 3, 3, 1 minus 2, 1, 0. It is 1, 2, 1. So B follows. This is what I told you. This is what I mean by B follows. All right. So this is step 1. Step 2, we had this formula. Now it is now 1, 2, 1. The projected point is 0, 2, 1. We drew normal. We understood the sine, cosine, everything. So it is B by D. D is root of B square plus C square. That is 2 square plus 1 square root 5. Sine alpha, cos alpha is this. L, you can skip this in step 2A, which will come here. This mathematics can be skipped. So in Rx of alpha, we had this formula 1, 0, 0, 0, 0, cos alpha minus sine alpha 0, sine alpha cos alpha 0, 0, 0, 0, 1. So we got the sine alpha cos alpha values, substitute here. Step 2B, not 3. Step 2B, rotate this via beta on z axis. So sine beta cos beta, that is d by 1 in our case. In his case, it is not a unit vector. It is d by root of a square plus b square plus c square. That is what in the previous step he has done. It is root 6. So it is 1 by root 6 can be written as root 6 by 6. To make you understand, this 6 can be written as root 6 into root 6. So numerator root 6 and denominator root 6 gets cancelled. It remains with 1 by root 6. So Ry of beta, substitute in Ry beta formula. This is the matrix. Step 3 is rotate, because you merged to z-axis, rotate now to 90 degrees with z-axis. Now what is this matrix? This matrix is this formula, cos minus sine 0 0. Yeah, because we have merged onto z-axis. The only job is rotate the object via z-axis. This is the ready-made formula, which is from 2D, 2D transformation, 2D rotation. 3D means because you're rotating via z-axis doesn't get affected. That is why it is 1. Cos, I mean, x-axis and y-axis remains here. Cos minus sine, sine cos. So here in this formula, you apply theta 90 degrees because he has told you rotate the entire cube by 90 degrees. So theta becomes 90. So cos 90 minus sine 90, sine 90, cos 90. So all those you apply here. Sine 90 z, I mean, what is the first one? First one is cos. So cos 90 is 1. Sorry, cos 90 is 0. Cos 90 is 0. Sine 90 is 1 because it is minus sine 90, which is minus 1. And sine 90 is 1, cos 90 is 0. You can see 90 degree. This is the formula. Now, apply in the last formula. That is, yeah, these are the inverse, guys. Apply in this formula as well. We will get all these 1 2 3 4 5 6 7, these 7, and multiply everything. You will get this. Now this is not the final step. This is only, mind you, this is r. You need to multiply this r with every point of vector, that is your cube. You see this 0.16 minus 0.075, this is the r into p. Now how did we get this p? You can see here there are 8 columns and 4 rows. Forget about the fourth row, that is homogeneous, everything is 1. Now you can consider first column 0 1 1, 0 1 0, 1 1 0. What are these? Well, yeah, those are these guys. You can see 0 0 1, 0 1 1, 0 0 0, 1 1 1. So these you need to put it into column measure. 0 1 1, 0 1 0, 1 1 0, 1 1. These 8 guys. Because it's a cube, we have 8 coordinates. I mean, 8 vertices. Each vertex has x, y, z. Fourth row is purely 1 1 1, homogeneous. Now multiply these, you will get this 2.650. Okay, what is the meaning of this mathematics? Now, originally, a point is at 0 1 1. Let us take this first column. First column, the point is 0 1 1, means where is 0 1 1? Yeah, this guy. So 0 1 1, which is here, if you rotate this cube via 90 degrees anti-clockwise, 0 1 1 will now come to which point? That is the question. So the answer is 2.650 minus 0.558, 1.467. Okay, let us take the last column, that is 101. Like this, you, apply for all. One more example, last column 101. So last column 101 means, yeah, this guy 101. 101, you're rotating. If you rotate this point 101 90 degrees anti-clockwise, where exactly this 101 will now come to? The answer is 2.891 minus this, so this 0.076. So this is how you should understand any theory by applying the correct mathematics. It's 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 not sufficient if you just know the mathematics. You should apply it. That is how we have done it. So 3D scaling and all, it is pretty straightforward, which 3D scaling, sharing, it's all reflection and all. It's pretty straightforward. And just to add another column called z-axis. So that finishes your 3D rotation, which you people had asked me to do it again. I hope you have now understood. And let me tell you once again, you can either follow mine or you can follow the textbook's um, vector multiplication, which you have anywhere written in all of your tests. I mean, in the second test, which I evaluated, I think around 40 to 50 guys have attempted the eighth question, and all those guys, 100%, they have followed the textbook's vector multiplication. And then people messaged me saying they haven't understood vector multiplication. So that's the reason I've done trigonometrical way. So I hope you have understood now. Um, any doubts? Okay, you can put it here. And I request you guys to mark your attendance. And thanks for watching. Have a nice day. Tomorrow we'll start module 5. Thank you.